Hello, I'm Uma. I'm the co-founder and CEO of Succinct. And today I'm going to be talking about how to build ZK applications with SP1. Okay. Okay. Oh, perfect. So let me start off by giving a brief description of what is a zero-knowledge proof. So kind of ZK 101. A zero-knowledge proof is a cryptographic primitive that lets someone prove to someone else that a statement is true without revealing any extra information. So you have a prover who can generate a proof that a certain computation, when applied to inputs, results in some output. And then the verifier can verify the proof and determine whether that statement is true or false. And there's two properties. One property is the succinctness property, which is the verifier can verify a proof in much less time than it takes them to do the original computation. And then there's the zero-knowledge property, which is the prover can hide inputs to the computation so that the verifier doesn't know about these values. So we probably know what ZK is. But so far, ZK has been full of promises, but it's been really, really hard to use. And that's where what we're building at Succinct comes into play. So what we're building at Succinct is a ZK VM, short for a ZK virtual machine, that makes using ZK as easy as writing normal code. So on the left-hand side, you kind of have the old way of doing ZK, which is very difficult. And it's kind of the circuit model of the world. It looks, like a different language. It looks very complicated. And on the right-hand side, you have using ZK with our ZK VM SP1, where you can just write normal Rust code and use any libraries or crates that you want, and then you can generate a zero-knowledge proof. And SP1, our ZK VM, is known for being very, very fast and performant, which is necessary when you're trying to generate zero-knowledge proofs of large-scale computations, for example, rollups. So you can see from this graph that when we released SP1 a year ago to now, we've gone through a ZK Moore's law, where performance is improved month over month. And in general, we've improved our performance by a factor of between 20 and 50x from when we started, which is very impressive, and these numbers are only going up more. And then finally, our ZK VM SP1 makes ZK really easy, it's very performant, and the final piece is the Succinct network, which is a protocol we're building to make using SP1 fast, easy, and cheap. So the protocol, it connects applications who want to use ZK. So for example, layer 2s, rollups, bridges, privacy, identity use cases that are using SP1 to a bunch of provers across the world who are generating proofs. And you might ask, why is it necessary to have all these provers generating proofs for a ZK VM? And the answer is that while you can use SP1 on a computer like your laptop, it's not going to be very efficient or very performant. To fully maximize the performance of our ZK VM, you need to use things like GPUs and one day maybe even custom hardware that's not available on your laptop. And so the goal with our network is that we're incentivizing this global distributed hardware build-out where there's going to be a bunch of data centers all across the world with GPUs generating proofs, kind of similar to something like Bitcoin mining, and making ZK cheap, fast, and easy. And when you use SP1 and our ZK VM, you can just send a request to the network, someone will generate a proof for you, you'll pay them through the network, and then you're going to get your proof very fast and very cheap, and better than you could do yourself. So what I like to say is that when you combine SP1 and the Succinct network, you get this new paradigm of ZK, which we call ZK 2.0. So the old way of doing ZK and ZK 1.0 and the kind of model that you guys may have been used to with existing ZK rollup stacks is that you'd have to have a whole cryptography team who are building a rollup and building their own proof system and then also deploying their own prover and having to do all these things over the course of many years with many, many PhDs and cryptography researchers and engineers. And it was a very long, complicated process. With SP1 in our network, you get ZK 2.0, where you have this very broad platform where you can just write normal code and use ZK. Then you can use our network to get proving instantaneously, so no need to set up your own proving infrastructure. And then you can build whatever applications you want by just writing normal code. So I like to say ZK 2.0 is general purpose because you can write whatever application you want, it's fast, and most importantly, it's super easy. So ZK 2.0 is super awesome, and it's kind of this new paradigm of ZK. And now the question to ask is, what can we build with this? So the most obvious use case for ZK that has been true for the past several years is ZK for blockchain scaling. Inherently in a blockchain, you have decentralization, which imposes an overhead from requiring redundant computation. And the succinctness property of zero-knowledge proofs fixes this and makes it so that blockchains can have unlimited scale without sacrificing verifiability. So one interesting thing is typically people think of ZK as only useful for something like Ethereum. And here I have a piece of the Ethereum roadmap where the parts that utilize ZK are highlighted in pink. But in reality, actually, even all ecosystems outside of Ethereum are kind of realizing that ZK is the way that they're going to scale. And you can see this overall trend where verifiable TPS secured by ZK is only going up. And so you can see there's a popular concept of Bitcoin layer 2s, Celestia's modular rollup-centric roadmap, and even things like Solana network extensions that are all leveraging ZK for scaling with verifiability. So ZK is for every single ecosystem, not just Ethereum rollups. Another interesting trend to observe, and why ZK for scaling is so compelling, is that I think proving will kind of be the ultimate form of security and verifiability for all chains. So in the past, if you wanted a decentralized verifiable chain, your options were proof of work mining, which is very, very wasteful because you have redundant computation. Or you have proof of stake, but that's actually pretty expensive because you have to give out these staking rewards and emissions to validators to secure the network. With ZK and a rollup-centric architecture, you can place your data on some sort of data availability layer, like Ethereum or Celestia or other options, and then you can get unbounded scale and verifiability with a ZK proof. And so to give you an example of kind of like the scale of how much more efficient and cheap ZK is, here is a graph showing, or here's a chart showing how much top chains pay out in staking rewards per year. And you can see that's in the billions of dollars or hundreds of millions of dollars. And all of that is simply much more efficient if you just use ZK for verifiability as opposed to paying all these decentralized validators to execute redundant computation to secure the chains. And then finally, some back-of-the-envelope math on why ZK is interesting for scaling in a large market is that if you kind of do some napkin math and you show that each transaction might pay something like 1/10 of a cent for proving, and you multiply out the numbers, and maybe you get to something like the number of roll-up transactions that are secured by ZK goes to 5,000 TPS, which is what Solana does today, that ends up being hundreds of millions of dollars in revenue per year dedicated to proving. And that's not even counting the fact that transactions per second are only going up. So for example, transactions on L2s have 15x'd over the past 5 years, same with Solana. So you can imagine that ZK gets cheaper and cheaper, transactions on these ZK rollups go up more and more, and that actually ends up being a very substantial amount of revenue devoted towards proving. And then the final piece I want to talk about for ZK for blockchain scaling is that just because we're doing ZK rollups doesn't mean they're ZK EVMs. So a lot of the use cases these days for ZK rollups, especially on Ethereum, is taking the Ethereum virtual machine and wrapping it in ZK. But actually, the EVM itself has a lot of overhead and poor design patterns for high throughput specialized applications. And you can imagine that in the future, very large scale specialized applications, for example, things like verifiable exchanges or verifiable perp dexes, will be written directly in Rust for a ZKVM environment instead of going through an EVM. And so I think this next generation of verifiable applications that are directly being proven in a ZKVM will kind of dominate the story of ZK for blockchain scaling, going beyond just the ZK EVMs that we know. So I've kind of outlined kind of the bullish thesis for why ZK in blockchain scaling is important and is going to be very big and result in a lot of proof demand. And now I can touch on how we're actually building this and deploying it in practice. So OP Succinct is kind of our first steps towards realizing this ZK rollup vision. And what it does is it combines the OP stack, which is a common rollup stack framework used for making EVM rollups. It combines that with SP1 or ZKVM and makes it so that you can get a one-click upgrade to a fully Type 1 ZK EVM rollup. And there's a lot of benefits if you're a rollup operator. You get 1 hour finality and better security. And it shows this broader trend of how every rollup one day is going to become a ZK rollup and how this paradigm of ZK 2.0 with a ZKVM can upgrade all existing stacks and infrastructure. And OP Succinct adoption is on the rise. So today, we have customers like Mantle, who have over $2 billion in TVL, and Fala, which is a TE-based blockchain, or a blockchain to settle TE-based systems, that's been running OP Succinct live on their mainnet since January. And we have a bunch of other infrastructure partners that are supported for OP Succinct and our ZK rollup vision. I think another interesting thing, and the final thing I want to touch on, is beyond ZK for scaling blockchains, which kind of already gets a lot of attention, is how ZK 2.0 can have impact even outside of blockchains. So one interesting thing outside of blockchains is today, if you want to prove to someone else information, you actually have to reveal a lot of information about yourself and potentially private parts of your identity. And ZK can actually help fix this problem. So to go through some very concrete examples, if you want to rent a house or buy a house, often you have to provide your entire bank statement and income history. But imagine a world in which you can instead provide a zero-knowledge proof of your income requirements and reveal or prove to someone that your income is over a certain amount without revealing anything extra. Today, if you want to prove your age or nationality, you often have to provide your entire driver's license information or passport in clear text. But in the future, you can imagine that you provide a proof of an email address or proof of passport and reveal only the fields that you want exposed, as opposed to revealing your entire identity. And similarly, today, if you want to show ownership over an address, an on-chain address, email, Twitter, in a set of accounts, for example, for airdrops or NFT mints or whitelists, you have to prove ownership of a specific account. And then that identity can be tied to your resulting on-chain identity. But with the zero-knowledge proof, you could instead prove a membership inclusion where you show you're part of a set without revealing who exactly you are in that set. And so this general theme of ZK identity protocols, where you take some identity information and then you hide certain fields and then you only prove the statements you want. So for example, in this diagram, it's that you're over 18 without revealing your name or your specific date of birth, has become a bigger trend. And now there are several protocols, including ZK email and self protocol, that can prove your email or passport or other information using zero-knowledge proofs that I think are really interesting use cases of ZK even beyond blockchain scaling. The other category I'm excited about for ZK outside of blockchains is replacing trust. So today, there's a lot of situations where we have to trust institutions or regulations to kind of run the right algorithms or do the right thing. Examples include credit scoring agencies, where you have to trust that they're running unbiased or fair algorithms to determine your credit score. Similar situation with insurance providers, who run trusted algorithms on your private data to determine your premiums. And then finally today, if you see images on social media or on news websites, you have to trust that the editor is giving you a real image as opposed to an AI-generated one. With ZK, a lot of this trust can be replaced with verifiable proofs. You can imagine a future in which credit agencies or insurance companies do verifiable machine learning with ZK email to show that their algorithms are provably fair, instead of you having to trust them. Similarly, you could imagine that in the future, you can combine a attestation from a hardware camera device and show that an image originated from a real camera with a set of verifiable transformations to prove that an image is authentic instead of dreamed up by Midjourney or ChatGPT. And actually, at a hackathon, someone built an attested verifiable image editor with SP1 for that attested image editing use case, where you can take an image, apply verifiable transformations, and then generate a ZK proof that the image it actually comes from a real camera, which is very, very cool. So the moral of the story is, overall, ZK 2.0 is here. With SP1 and our network, you can now build anything with zero-knowledge proofs. And I think it's going to be a big theme of blockchain scaling in the upcoming years, very obviously, but even a lot of exciting applications outside of just blockchains for verifiability. Thank you.